Why do triangles have 180 degrees? Why? Okay, how about this? Imagine a triangle, where the two base angles are 0 degrees and the top angle is 180 degrees. You basically have a straight line. Can you see why the sum of the angles in this triangle is 180? Because two angles are 0 and top is a straight line, and a line is 180 degrees. If you can agree that this answers the why for this specific triangle, then proceed. Imagine you can pull the top corner up a little. What will happen? The two sides of the triangle move up a little and the triangle now has space area. The top angle is less than 180 degrees, no longer a straight line but an actual corner, and the two bottom angles are also not 0 anymore. As you pull the top corner up, the top angle gets smaller, and the bottom angles get correspondingly bigger. It's only natural that the total will therefore stay at 180, but this doesn't prove it, only explains the why. For the proof that the total is 180, see other answers that have been posted, for example Philip Lloyd's. Augmented the 5th of May 2020, if you pull the top corner straight up higher and higher, the angle at the top will get smaller and smaller, approaching 0 degrees, whereas the two bottom corner angles will approach the vertical, i.e. 90 degrees each, so still totaling 180 degrees. This is a consequence of Euclid's fifth postulate axiom, telling that through a point outside a given line there goes one and only one line parallel to the given line. Take pencil and paper. Draw a triangle ABC with base AB and top C. Now draw the line parallel to the base through C. The left outer angle of C is equal to the left inner angle cab. This is a theorem about angles of two parallel lines intersected by a third. It depends on the fifth postulate. The right outer angle of C is equal to the right inner angle CBA. And because ACB is obviously equal to itself and a straight angle is 180 we have proved our theorem. In non-Euclidean geometry that discards the fifth postulate, this is no longer true. In spherical geometry, yes, that exists. You may draw a triangle beginning at the North Pole, follows a great circle the equivalent of a straight line to the equator, follows the equator to 1/4 of the circumference of the Earth and follow a great circle back to the North Pole, and now you have a triangle with 3 right angles. There is another approach halfway between the tearing up a triangle and the parallel line proof. Introduce the idea of congruent transformation, so with 3 identical triangles translate one along the baseline C beyond side A, so at the right hand corner we have angles A and B and a gap, which you fill by rotating the third copy of the triangle about the midpoint of side A. I've just thought of another proof. Lemma the angles in a right angle triangle add to 180. Take an arbitrary rectangle. This has point symmetry. Draw one diagonal. The two congruent triangles so formed have angles that total the angles in a rectangle, so those two triangles have angles adding to 180. Now take an arbitrary triangle, put the longest side on the baseline and construct an enclosing rectangle. We now have a scalene triangle and 2 right angle triangles. So an angle sum around the 3 triangles, we find we have 4 right angles in the corners of the rectangle and 1 straight line, totaling 6 right angles in 3 triangles, and so 2 right angles each. The sum of the angles in a triangle is 180. Why? You are no doubt aware that a 180 angle is called a straight angle, and is the measure of the angle formed when the 2 rays which make up the sides of the angle form a straight line. Now let's draw a triangle increment ABC. From any one vertex, C, draw a line through that vertex that is parallel to the other side of the triangle, side AB. You will have formed 3 angles at that vertex: the original angle ACB, which we will call angle 2, the angle on the left side of angle 2, which we will call angle 1, and the angle on the right side of angle 2, which we will call angle 3. It should be clear to you that angles 1, 2, and 3 add up to 180, since their exterior sides form a straight line. We now use one of the properties of parallel lines, namely, when 2 parallel lines are crossed by a transversal, the alternate interior angles formed are congruent. So, using the side of the triangle AC as the transversal for your parallel lines, you should see that angle A and angle 1 are alternate interior angles and therefore congruent. Now use the side BC as the transversal, and note that angle B and angle 3 are alternate interior angles and are therefore congruent. Since we know that angles 1, 2, and 3 add up to 180, we can replace angle 1 with angle A, angle 2 with angle ACB, and angle 3 with angle B and see then that they add up to 180 as well. Let's geometrically understand how a triangle can be easily formed in figure on a plane having 2D elements. If we try to pull up one of the straight line out of the two or more overlapped straight lines, from the center, of any convenient point, it would appear to be a triangular shape of geometrical figures. The center of a straight line represents a 180-degree angle because if the same line is rotated from that fixed point it would come back to its original position, completing a circumferential figure we call a circle having 360 degrees. The line radius and the extension of the radius through the center as diameter, which was used to make the triangle, represents 180 degrees. It's a fact that a diameter bisects the circle, creating two identical half circles. Another statement is that if three coplanar lines are drawn to form a triangle, the total angles outside the enclosed triangle amounts to be 4 right angles, and since a straight line represents 2 right angles or 180 degrees, 3 lines must have 6 right angles. If the measurements of the outside angles are 4 right angles, then the enclosed angles by the triangle should be 2 right angles or 180 degrees. The universal formula for measuring the angle created by the polygons is that 2 and 4 right angles. In the case of a triangle it also applies. 3 by 2, 4 equals 2 right angles equals 180 degrees.